Hello everyone. In this video, we will be talking about structural analysis. So over here in this drawing, we have a normal structure. We have link AD, link DC, AC, and so on. Now notice they are all in triangular shape. The structure has to be all made up of triangular shape, otherwise it cannot be in equilibrium. So for this whole thing to be in equilibrium, the sum of the forces at each pin, that is, the sum of the forces at D, sum of the forces at C, blah blah blah, has to equal 0. Otherwise, it will break and it's not an equilibrium then. So if we take, for example, D, we have two forces on it. These has to be the sum of these forces has to equal 0. And in this chapter, we were only going to be talking about forces that are applied on pins. So we cannot have an example of a force that is acting like this, force F. We will not be doing this here. Okay, so I guess this is a quick introduction. So to get started, let's say we have this three-link setup over here, AB, ABC. It's a right triangle, 45 degrees, and of force 500 newtons applied at B in the X direction. So X and Y. So to get started, we know here we have reactions AY, AX, and CY. Notice there's no CX as it's a ball, so it's free to move in the X direction. So if we do the sum of the forces in the X, we have the 500 newtons, this is this one, and minus FBC sine 45. This way we get, now notice, AX equals FBC sine 45. It's the same thing. So we know that FBC is 707.1 newtons, and doing the same thing, summing the forces in the Y direction, we have FBA equals FBC cosine 45. Now notice in this I'm referring to this picture. I did the free body diagram at pin B. We have the 500 newtons here. We have the FBA and FBC. Now if you look carefully at this, so taking a break a little bit from doing calculations. Now this 500 newtons force, when it's applied in this direction, if you look at link BA, it's going to be moving this way. So it's in tension. This is why I have tension here. And FBC is going to be moving that way, so I have compression. Okay, so to keep going, FBA is FBC cosine 45, so we get FBA is 500 newtons. And actually forget about AX, AY, and CY. We don't need to get those in for this problem. Now let's look at the pin C. So what forces do we have there? We have the reaction CY, we have FCA, and we have FCB. Now if you look, FCB is the same thing as FBC. So FCB equals FBC. This is very, very important to note. So if you do the sum of the forces in the X direction here equals to 0, we know that FCA equals FCB cosine 45. This is 45 degrees. And so we can get FCA is 500 newtons. FCB is this the 707.1. So 707.1 cosine 45 equals 500. And then if we do the sum of the forces in the Y direction, we only have two forces, CY and FCB cosine 45. So same thing, same value. So we get CY is 500 newtons. And also we can do the at pin A. Let's see, what do we have? We have AY, we have FBA, and also we have FAC. Now if you look at directly, you can tell that FAC is 0 because we don't have any to keep this in equilibrium. We need the sum of the forces in X equals 0, and FAC is the only force, so this has to be 0. And so now we have AY equals FBA, which we got from here. FBA, this is gonna be 500 newtons. Now remember at the beginning of this problem I said that AY is AX is this. Forget about that. Okay, so moving on. Next we'll talk about zero force member. So what is a zero force member? It's basically a member that has no forces on it. Now this can be concluded just by an inspection simply. So let's look at this links. Let's look at these links. So if we look at AFB, notice A. Let's take that by itself over here. What two forces do we have on it? Oh, let's for example say that we have, let's put a force B here, it doesn't matter. So on A, what forces do we have on it? We have FAF and FAB. Now if you look at these, they're perpendicular. So if we do the sum of the forces in X equals 0, what do we have? FAB equals 0. Same thing, doing sum of the forces in Y equals 0, FAY equals 0. Sorry, FAF. So now both forces are 0, thus we have a zero force member. And also D, let's look at that member. We have FDE and we have FDC with theta between them. Now there is no way that we can have a value for both of these forces and have it in equilibrium, simply because FDC with this direction, if we extend it here, we have here FDC y prime. Let's call this x prime and y prime. This is x prime is the direction of FDE. So we have a part of FDC that is in the direction of y prime. So the same thing, doing sum of the forces in x prime equals 0, sum of the forces in y prime equals 0. So we have FDC cosine 90 minus theta equals 0. So FDC is 0. And doing for FDX, we have FDE minus FDC cosine theta equals 0. Now we have from this that this is 0. So we know that FDE is 0. Now, to keep going, now I will talk about another method to solve these sorts of problems. So let's say we have this assembly of links over here, A, B, C, D, E, G. So I want to know, I guess, let's say we have the forces 400 newtons here, 1200 newtons here. Now the first thing we can get out of this is, let's get AX. So first, of course, we have AX here, AY, and DY. So if we do the sum of the forces in the X direction for the whole assembly, we only have AX, we only have the 400 newtons and AX, so AX is 400 newtons, very simple. Now I want to get DY, I can sum the moments about point A, so I have 400 newtons as a moment. Now all of these links, this is 3, now dimensions doesn't matter really to get the point through. So if we do the sum of the moment about I, we can we know that dy, we can get that to be 900 newtons, simply by doing 400 times 3, 1200 times this distance, and dy times the whole length over here. Now we get dy, and then at the end we can sum of the forces in the y direction. We get ay to be 300 newtons. Now I want to make a cut over here. I want to get the forces in the lengths. So I make a cut A. Let's draw this. So we have A, G, B, and here. So what forces do we have on this part? We have AY, AX, which we already got. We have FBC, FGC, and FGE. I want to get all of them. So what can we do? It's very easy. Look here, we have FGC and FGE. They both meet at G, so they don't have any moment about point G. And we already know AX, AY, and AX. So if we sum up the moment about point G, we can get FBC. Very simple. So we do AX times 3, FBC times 3, minus AY times 3. We have everything. We have AX, we have AY. We can get FBC. Now next we can sum, let's see, if we sum the moment about point C, which is over here. Notice both these forces, FGC and FBC, meet here, so they don't have any moment. So the only unknown we have is FGE, because we have AY and AX. So we already got those to be, we can multiply them, and oh sorry, AX has no moment about point C. If we elongate, it meets at C. So we only have AY, which is 300 times A. This is actually 4. This is 3. Oh sorry, 4 and 4. So the distance D is 4 plus 4. This is where I got this number. And FGE times 3. This is going to be the 0. We get FGE to be 800 newtons. And finally, final step, we can sum the forces about Y is 0. The only unknown now we have is FGC. We can get it to be 500 newtons. And I think this basically sums this chapter, structural analysis. Also, there are more problems that can be solved to get more familiar. It's very good to do a lot of exercises in those, so you can get very fast in solving them, and it shouldn't be any problem. Alright, thank you everyone for listening.